All right. What is great about Le Chatelier's principle is that it's really applicable to us. How we can have things in common with a chemical reaction. So, the basic premise of Le Chatelier's principle is that when you stress something out, that thing is going to try to undo the stress. So, for example, with humans, if we were to go outside and it was very hot, we'd say, oh man, it's hot. It's too hot. We would want to do things to cool us down. We might take off a jacket or take off a hat to feel cooler. Or it was the opposite. If it was too cold, we might want to put on a jacket. We would just want to do something to undo the stress. If we're really hungry, we want to get food to undo the stress. Chemical reactions are the same way. And Le Chatelier found that when certain stresses were put on, we call it a system, that means the chemical reaction, that it would act in a way to undo that stress. Now, chemical reactions, they're limited in what they can do. They can't take off jackets, they can't put on jackets, they're not humans. The only thing a reaction in equilibrium can do is speed up the forward reaction or speed up the reverse reaction. And we've talked about equilibrium with the dance analogy with the gym and the hallway. The only thing it can do is speed up how fast people come into the gym or speed up how fast people go out into the hallway. That's the only choice that a chemical reaction really has. So, for example, let's look at something as stress might be, an example of something. So here I just have A plus B makes C. Well, let's say we put a stress on the system. A scientist is going to come in here and, it's in a beaker in the lab, and let's say that scientist adds more A. Well, what's the stress? There's too much A. The reaction is saying too much A, too much A. It wants to undo that. How does it undo it? Well, let's think about it. Would speeding up the forward reaction or the reverse reaction help us get rid of A? Remember, we have too much A. We want to get rid of it. Notice that when we go this way, A gets used up. So we want to speed up this reaction to get rid of that extra A. And the phrase we use with Le Chatelier's principle, when we say we want to speed it up that way, we're going to shift to the right. Sorry, shift to the right. That's the phrase. Let's look at another example. Let's say the scientist comes in and adds more C. What's the stress? Too much C. What does the system want to do? Undo it. It needs less C. How do we get less C? Do we speed up this way or this way? Well, if we speed up this way, the C will get used up. So we want to, the phrase is shift to the left. Let's look at another example. Another way we can stress this out is by taking something out. Let's say the scientist has the ability to remove B. What's the stress? There's not enough B. We need more B. There's not enough. So what does the reaction do? Is it going to shift left or right? Remember, not enough B. We want to make more. Making B, that's this way. So it's going to shift left. Now, I don't know how complicated your problems are going to get, but another option is sometimes they'll, I'm trying to wonder if you'll have to do that. With heat, let's say, sometimes you might see that they'll put in heat. So I just want to kind of give you a more complicated example. Well, here, let's say I put this whole thing in the freezer. I put the whole reaction in the freezer. What's that stress? Well, think about it. If I'm in the freezer, it's like I'm removing the heat. If I'm removing the heat, that's stressing it out, saying there's not enough heat, there's not enough heat. The reaction wants to make more heat. Which way do we shift to make more heat? Well, it's over here. We want to make more going that way. So we're going to shift right.